Alright, welcome to the morning time video. So sometimes it's rare to make that video, not so much today. So yeah, lots of time today. So let me switch this over to bookmarks. There we go. So here's the bookmark. Last video we had to go skip through everything because it was just taking too long to do things on my local hardware. Now there is a way we can speed it up. I think we can change it so that we're doing things in the way the current version of Pandas wants us to. What it wants us to do is anytime we have an append statement like this, it wants us to convert the object that we want to append to the data frame into a into another data frame. Currently, we can see it's actually a list, or sorry, it's actually a dictionary usually. So what we can do is get rid of some of those warnings, and hopefully that will cause it to go faster by taking some of these statements where it's clear it's a dictionary. We know what's going on. Sometimes it's a bit tricky because the statement is working with an object that we can't really see too easily, like for example here. So we don't know how to convert that to a data frame. But these it's really easy to just convert this to a data frame. So let's do that, and let's just for each of the ones that are really easy to convert to a data frame, let's do that, and hopefully that will speed up the notebook. So what we're gonna do is copy this, paste it into here, and now we're going to figure out if we can convert this to a data frame really easily. So we're going to do that, inventory entry. Oh, so it looks like we're not able to easily convert it to a data frame. So let's go to ChatGPT and ask how I can convert this dictionary to a data frame. This is kind of what ChatGPT is made for. So how can I convert this Python dictionary to a data frame, to a pandas data frame? So remember, okay, so you have to put it in a list. So that's all you have to do, because then you give it the rows and columns. You can think of it because a data frame has. Let's go back to the shell here. So we have some example data frames. We have example data frame 1, we have example data frame 2, and then we have object 3, which is not a data frame. It is a dictionary. So if we look at the data frames, we see it has a row and it has a column. So in row 0, we have the word hello, and that's in column 0 as well. So we have row 0 and we have column 0. So what is a dictionary? A dictionary is a key value pair. So that'd be great for rows. For each row, we could have another value. But what about the columns? Well, what you can do is you can create a different object. You can create a list, and each list has and then that will have rows and columns the way you define it. So I don't think we have a df4 yet. Nope. So we don't have a df4. So let's test this, and let's create a list. And then each entry in the list will be a dictionary. So we're going to create 2 dictionaries like that. And then we're going to have we're going to have a key 0 here, and it's going to say hello. And then we're going to have a key 1 here, and it's going to say world. All right, so this is quite a different object than we have in data frame 3. So data frame 3, if we do a type on it, it's a dictionary. Data frame 4, if we just show it here and then do a type on it, it's a list where each element in the list is a dictionary. So quite a different object type. It's a whole different object type. It's a list and not a dictionary, even though it contains dictionaries. So what happens with this with converting it to a data frame? So we have two variables here that are not data frames. We have df3, which is a dict, and we have df4, which is a list. So we've tried it already with df3, but let's try it again. df3 is a dictionary. Oh, so that doesn't work. We must pass in an index. So what has indexes? Lists have indexes. So let's try it with a list. And there we go. We've got it to work, and we can see the structure of it is very close to what we would expect in our definition of this data type. So this is a list data type, and we can see we assigned hello to row 0, and then to row 1 we assigned world. And the other thing you can see, which is kind of interesting, is they were automatically assigned to columns based on their index in the list. So hello was in index 0, so it automatically got assigned to column 0. World was in index 1, so it automatically got assigned to column 1. Within the dictionary itself, they were assigned based on the key of the dictionary. So let's try this next. Let's change the key of the dictionary, and we're going to say row 1. We're going to change it to a string instead of a integer. And then the next one will be row 2. So the data type is completely different. The actual, what it says is completely different. And let's see if this converts to a data frame. All right, so it converted to a data frame perfectly fine. But we can see there's something kind of strange going on. I misunderstood what those mean. So it actually means the opposite of what I was saying. The index in the list corresponds to the column, whereas the key of the dictionary corresponds to the index of the list corresponds to the row. It was hard for me to say because it says row right there, so hard to formulate those words when the words you're looking at are the opposite of what you're trying to formulate. But when you think about it more carefully, it makes a lot of sense, because the columns could be anything. You know, the columns don't have to be a number. Like, let's say you're doing a budget. So the columns, which we're going to define in the dictionary, could be rent, could be groceries. But the rows, the way Pandas does it, and there might be a different way to do it, those are going to be numbered. So if you have two properties, you're going to have two rent payments. So they're going to be numbered 0 and 1, but you can change your. I guarantee you, there's a way. You know what? This is good. Let's ask ChatGPT. So, okay. So we're just putting this in. There we go. Yep. Okay, so I'm understanding it a lot better now. Okay, so I'm understanding this a lot better now. I'm understanding specifically that what you can do to create a data frame is you can create a Python list object where the indexes of the list will be converted into the rows of the data frame, and the the data object defined in the key of the dictionaries, which constitute each element in the list, will be used for the columns of the data frame. Now tell me this, is there a way I can change the data frame that you saw in the prior prompt where the words rent and groceries are in the rows labeling rather than in the columns labeling, and the columns labeling are 0 and 1 rather than the rows labeling. Off the top of my head, thinking about this, I don't know how it could be the case because each index in a list is automatically labeled 0 through however many indexes there are. So how could you change an automatically labeled index to one that is labeled by user input? Oh, yeah, I figured you probably could. Transpose.
Yes, you can achieve this by transposing the data frame. Transposing essentially swaps the rows and columns so that the original columns become rows and the original rows become columns. Here's how you can do it. Create the data frame as you did before. Use the transpose method, or t-attribute, to swap rows and columns. Here's the modified code to transpose the data frame. The output will be, in this transposed data frame, the original row labels rent and groceries are now the row indexes. The original column labels 0 and 1 are now the column indexes.
All right, but what if I want to do something like create a Punnett square or like a game theoretic square where both the rows and the columns have custom labels?
To create a data frame that resembles a Punnett square or a game theoretic matrix where both rows and columns have custom labels, you can specify the index for rows and columns directly while creating the data frame. Here's an example of how to create a data frame with custom labels for both rows and columns. In this example, data is a dictionary where keys are column labels and values are lists representing the data in each column. Row underscore labels is a list of custom labels for the rows. Column underscore labels is a list of custom labels for the columns. The resulting data frame will look like this. This approach allows you to fully customize the labels for both rows and columns in your data frame. If you have a specific Punnett square or game theoretic matrix in mind with specific data, you can adjust the data, row underscore labels, and column underscore labels accordingly. For example, creating a Punnett square for a genetic cross might look like this. The resulting data frame will look like this. This creates a 2x2 Punnett square with custom labels for both rows and columns.
Okay, so yeah, we have the dominant gene and the recessive gene from the mother, dominant gene, recessive gene from the father, and then we have the combinations of whether or not the child will have the dominant characteristic expressed by the gene, or the for example, and this is from education in this sort of thing from probably the 1990s. So I'm sure it's come a long ways since then. So, okay, I understand now a lot better. So you can figure out the dominant and recessive traits using a Punnett square in pandas. Now, my knowledge of this sort of thing, gene expression, dominant recessive traits, Punnett squares, probably comes from the late 1990s. And I guarantee you that progress in this field has become so advanced that basically I know completely incorrect information about this whole thing at this point. So act as an expert in this domain of knowledge and update my information briefly to a, like a 4th grade level or like whatever grade I would have been in. I know I did learn a lot about this in freshman year of high school. So like give me a primer to bring me up to speed. I did learn about DNA and RNA in that freshman class. So like, it's not like I only know concepts that are completely obsolete these days, but give me like a good intuition or working knowledge about the advancements in this field and how they dwarf what was known in the 1990s.
Sure, I'd be happy to give you an updated overview of genetics and gene expression, tailored to a level that should be easy to understand based on your background.
And this is off topic, but
Basic
I
concepts:
have to
DNA
know.
and genes. DNA, deoxyribonucleic acid, the molecule that carries the genetic instructions for life. It is composed of 4 chemical bases: adenine, A, thymine, T,
Yeah,
cytosine,
I
C,
learned
and guanine,
that.
G. Genes, segments of DNA that contain the instructions for building proteins, which perform various functions in the body.
Yep.
Each gene is like a recipe and cookbook. Chromosomes. Humans have 23 pairs of chromosomes, 46 total, in each cell, except for sperm and egg cells, which have 23 single chromosomes. Chromosomes are long strands of DNA coiled around proteins.
Yep.
Alleles, different versions of a gene. For example, a gene for eye color might have an allele for blue eyes and an allele for brown eyes.
Alleles. Yeah.
Dominant alleles, expressed if present, e.g., brown eyes.
Okay, so it
Recessive
is.
alleles, only expressed if 2 copies are present, e.g., blue eyes. Advances in genetics genomics, the study of the entire genome, all of an organism's DNA. The Human Genome Project, completed in 2003, mapped all the genes in human DNA, providing a comprehensive reference. Epigenetics, the study of changes in gene expression that do not involve changes to the underlying DNA sequence. Environmental factors, such as diet, stress, and exposure to chemicals, can affect gene expression. These changes can sometimes be passed to the next generation. CRISPR-Cas9, a revolutionary gene editing technology that allows scientists to precisely alter DNA sequences in living organisms. This has potential applications in medicine, e.g., curing genetic diseases, agriculture, and research. Gene expression and regulation. Gene expression is the process by which information from a gene is used to build a functional product, like a protein. Regulation of gene expression ensures that the right genes are expressed at the right times in the right cells. This involves various mechanisms, including transcription factors, RNA splicing, and epigenetic modifications. Understanding Punnett squares today. While the basic concept of Punnett squares to predict the probability of offspring inheriting certain traits remains valid, our understanding of genetics has become more nuanced. Polygenic traits, many traits, e.g., height, skin color, are influenced by multiple genes, not just 1 or 2.
Yeah. Okay.
These are called polygenic traits. Incomplete dominance and codominance. Incomplete dominance. Neither allele is completely dominant, resulting in a blended phenotype, e.g., red and white flowers producing pink offspring. Codominance. Both alleles are expressed equally, e.g., AB blood type, where both A and B alleles are expressed. Genetic variation. Genetic variation is the diversity in gene frequencies. Mutation, recombination, and other processes introduce variation. Practical applications: personalized medicine, tailoring medical treatment to individual characteristics based on genetic information. For example, certain drugs are more effective in individuals with specific genetic profiles. Genetic testing. Testing for genetic conditions can inform individuals about their risk for certain diseases, guide treatment options, and provide information about ancestry. Gene therapy. Techniques to treat or prevent disease by directly modifying the genes. This can involve replacing a faulty gene, inactivating a malfunctioning gene, or introducing a new gene. Summary: DNA carries the instructions for life, organized into genes and chromosomes. Traits are determined by alleles, which can be dominant or recessive. Advances in genomics, epigenetics, and gene editing
So
technologies like
this is
CRISPR-Cas9 have
more or
revolutionized our
less-
understanding and capabilities in genetics. Modern genetics includes complex concepts like polygenic traits, incomplete dominance, and codominance. Practical applications of genetics are now seen in personalized medicine, genetic testing, and gene therapy. This should give you a good, updated foundation in genetics. If you have any specific questions or need further details, feel free to ask.
Okay, so this is more or less what I know and what I have learned. It's just if it's like a simple black and white, like they inherit this gene or they don't, it's more complicated than that because there's caveats like incomplete dominance, polygenic traits, and codominance. And there's been advances that didn't exist when I first learned about this stuff, like the mapping of the human genome and gene editing technologies.
Yes, exactly. You've got a good grasp of the key points. To summarize and expand slightly on what you've said, inheritance complexity is simple Mendelian inheritance. Traits governed by a single gene with clear dominant and recessive alleles. Punnett squares are straightforward for these traits.
Yeah, but it's not the only.
Incomplete dominance. Neither allele is completely dominant.
Right,
The heterozygous phenotype is a blend of both alleles, e.g., red and white
Yeah.
flowers producing pink flowers.
right.
Codominance. Both alleles are expressed equally in the phenotype. Example: AB blood type, where both A and B alleles are fully expressed. Polygenic traits. Traits influenced by multiple genes, often resulting in a continuous range of possible phenotypes, e.g., height, skin color. These traits do not follow simple Mendelian inheritance patterns. Advances in Genetics Human Genome Project, completed in 2003, it mapped all the genes in human DNA. Provides a comprehensive reference for genetic research in medicine. CRISPR-Cas9, a powerful tool for precise gene editing. Can be used to correct genetic defects, study gene function, and develop genetically modified organisms. Epigenetics studies how gene expression is regulated by factors other than changes in the DNA sequence. Environmental factors and life experiences can influence gene expression, sometimes across generations. Practical applications: personalized medicine, tailoring medical treatments to an individual's genetic profile. Can improve the efficacy and safety of treatments. Genetic testing identifies genetic predispositions to diseases, informs treatment options, and offers insights into ancestry. Gene therapy treats or prevents diseases by directly modifying genes. Techniques include replacing faulty genes, inactivating harmful genes, or introducing new genes. Summary: inheritance is more complex than simple dominant-recessive relationships due to factors like incomplete dominance, codominance, and polygenic traits. Advances such as the Human Genome Project and CRISPR-Cas9 have significantly expanded our understanding and capabilities in genetics. Applications of these advances are transforming medicine, agriculture, and various other fields. By understanding these concepts and advances, you can appreciate the nuances and potential of modern genetics compared to the foundational knowledge from the 1990s. If you have any specific questions or need further explanations on any of these topics, feel free to ask.
Okay, so got way off topic there, but in doing so, I learned a lot about data frames. So you can explicitly define what the rows and columns are, and you do that by when you define the data frame, here, you can say now you have to give it the correct keyword that was defined in the parameter definition. So you have to feed in an argument that matches that keyword, but it's going to be index and then columns. And index is another word for rows. Columns is is just one word. So if we do index, now we're going to say index will be equal to hello and world. All right, and then columns will be equal to, we'll do world hello with an exclamation point, so we know they're different. There we go. And now we've got a and I think df4. What is df4? Oh, df4 is not defined. But even though it was not defined, we were still able to make. Oh, that's d4. On df4. Well, that's interesting. Why isn't it showing like hello world for? Oh, because these don't match. I think that's why, because the columns don't match. Because remember, these are columns, column labels there, and they weren't show up. So if we change this for groceries, and then we change this for rent. All right. Now we should get now we get actual values because it knows where to put those values. And then it also knows where to put him in regard to the row, because it's going to put him in the 0th and first index of the list. And this list has the same amount of indexes, so it will know what to do there. So let's feed the list here another index. So we're going to say row 3. And let's see how it handles that. I think it should create just another row 3 with all not a number values. Nope, so it has to match. It's not that intelligent to just do that automatically. If your list of labels does not match your list of key value pairs, then it will not convert over properly. So we know how to do it now. We know how to. So we learned a lot about pandas. And about data frames and about how to convert non-data frame objects to data frames. So all we got to do is say inventory entry, and we'll use the same formatting as the offer, equals pd dot data frame. All right, and then within a list, so that it knows which row it belongs to, inventory entry. So this is an index with only one. This is a list with only one index 0. So it's going to belong to row 0. But the thing is, we're going to concat it with the existing data frame. So hopefully it should know to put it at the end of the existing and change that row label. So let's try that. So we're gonna say df. So we've got a df4 defined. We've got a df5 that's not defined. So let's work with that. So we're gonna say df5. So remember what our df3 looks. df1 looks like, all the way back to df1. Remember what that looks like? So there we go. And remember what df2 looks like. So that's a data frame as well. So let's try pandas.concat. Okay, and then we're going to have df1 and df2. Okay, so this is actually pretty fascinating. So it actually preserved that index. So now we've got a table with column 0, but then we've got 2 rows that are indexed as 0. So I could see that as being a problem. Now we do have this special flag here, ignore index equals true. So let's do it again with that flag and see how that makes a difference. And there we go. We can see it now relabels the indexes based on based on the index of the concatenated data frame. So if we have a larger data frame, so let's save this to df5. If we hit the home button and do df5 equals this larger data frame with 2 columns. Now if we concat df1, df5, which with 2 columns, with df2, and we make sure to include the ignore index equals true, now we've got a 3-column data frame. So that's how that works, and that's how it will work here if we edit the author's simulator code here. All right, so let's do that. So the most important thing is we need the ignore index equals true, and then the next important thing, we need to use concat, and hopefully that will speed the code up quite a bit. And now that I understand how it works, we actually might be able to go ahead and contribute this back to the author, because I can definitely get what the yeah. So now that I understand it, I feel comfortable contributing. Now, one thing I would like to do different here is I would like to put that suffix on there so that we know what's happening here. It's converting it to a data frame. It's not a data frame here, but it's a data frame here. So we're changing the name of the variable to reflect that. And there we go. That's all there is to it. Yeah, so now this can be used with the current version of pandas. All right, so all 70 instances. Here we go. Now some of these can just be swapped wholesale. As long as it's device inventory and inventory entry, it can be swapped wholesale. So let's do that. There we go. Device inventory and inventory entry. This can be swapped wholesale, but it has to be in the same. So there's 1, 2, 3, 4 here. So there we go. Oh, and I forgot to check. Yep, there's 4 just like the other one. All right, so now we're on to a different one. Now we're on to interface inventory rather than device inventory. So let's get that working here. Okay, so yep, this is still the same here, but now we have to change it to this. Oh, but it's already like that. Okay, so yeah, this is it. And there's now 3. Okay. Oh, so it looks like we've got a problem here. So it's right. We have to have this be underscore df as well. And I hope I did that for the other entries. I did. Okay. Perfect. 1, 2, 3. All right, 6. Oh, actually 7. 1, 2, 3, 4. I would just line it up with the closing brace. Okay, so now we've got a different one. We've got device metric policy. Okay, so this is correct. Yep, so we took this from the original location, so all we needed to do was work backwards, and now it's good to go. Okay, and actually this one looks like it's not meant to be aligned with, it's meant to be 2 before that, so that's important. Okay. And again, it's meant to be 2 before it. All right, this one's meant to be aligned, and it's the same device metric with a policy entry. And this is the same, policy entry, device metric, aligned. Oh, now this is device metric policy, which is different. So we're going to change this. And we can work backwards. Yep, so that's looks good to me. And it's going to be aligned. All right, so here's a different one. work backwards. Oh, and you know what? I've been doing this completely wrong. It has to look like this. Yeah, so I've been doing this completely wrong. Yeah, so oops. That's going to be a lot of work to go back and fix. All right, so now we've got event templates. I kind of wanted to go back and clean up the ones I messed up, so I'll do that. It shouldn't be that hard to do that. So, okay, yep, I've got to clean up basically all of them. Looks good to me. Oops. Okay, now I caught my error and I'm going back to doing things how they were. So I had 18 entries that were messed up, and I corrected all 18. All 18 are looking good with the concat rather than append, and with giving it a list so that it knows which indexes, and it knows to ignore the index, so to preserve the original indexes and then add this as a new index to that one. That's what that means. So, and I can do that for any number of indexes. All right, so here's the next one that hasn't been fixed yet. We're on to event templates, so let's go and work backwards and make sure to make the full change this time. All right, so the full change is we have to change this to concat. Then we have to change this to PD. Change this here to underscore df. Put this in a list. And then this actually needs to be changed as well up here. And this as well. So lots of changes needed for this one. Hopefully there's a lot of instances of it. All right, aligned with the brace. All right, next one, aligned with the brace. All right, next one, aligned with the brace. Next one is aligned with the brace. Aligned with the brace. Okay, so I think this is a new one now. This is an event policy, where these other ones were event templates. So we have to use a different one for that. Okay, I'm noticing there's some kind of error here. There's an unexpected indentation here. So I don't know why it's like that. Oh, I see. Because it's not aligned with the braces. There, it's not meant to be aligned with the braces here. So hopefully there's not more errors like that. There are not. Because it's in else statement. Perfect. Not aligned with the brace. All right, not aligned with the brace. Okay, not aligned with the brace. All right, not aligned. Or was it aligned? No, it was not aligned. All right, not aligned. And not aligned. Okay, lots more. These are aligned now, though. Yep, event policy is the same. Event policy. And it's aligned. Event policy. And it's aligned. Oops. Okay, so now we got a new one here. The last one was event policy, and this new one is now incident policy. Okay, and I do have some time to finish this out, so hopefully that can happen. All right, so let's align it. And we're going to align it. And align it. Oh, I think I blew it away. No, it's the same. It's the same. Good. And it's aligned. All right, only 4 more entries. Okay, and here's where we're just going to skip this one and use the append method. We'll get a warning for this one, but that's okay. Now, with what I've learned here, with what we've learned here, we could actually see what this is, and figure it out. If it's something different than what those other ones were, we now have enough knowledge to convert it properly where we did not before. So that could be exciting. But for now, I just want to get to a better place here. Just incremental progress is good. All right, and this goes in the for loop. Now this is metrics df, metrics object. So that's different. That was events. Okay, and I have a feeling for some of these I forgot to do the concat conversion. So let's go back and look at some of them. Yeah, so I didn't change this to concat. And I think that's probably true for a bunch of these, so let's go back. Yep. Oh, that's the one I skipped. But yeah, it's going to be true for a bunch of these. Probably, yeah, a lot of them. What we can do actually is just swap out all of pd.append for pd.concat. Since we had to change it like that, it should be pretty easy to swap out. But for now, I'm just going to go through one by one. I am running out of time here. So this is not the best way to do it for sure. It's better to do it that way. So you know what? Let's do it that way. I'm running out of time here. So we'll just do a few more entries here. 2, 3, and now this is too slow a method, so let's use a faster method. We're gonna do, we're gonna search for pd.append. So oh, I literally had just one more to go. All right, well then let's fill that in. Okay, so now okay, well, shoot. Okay, so now we've got we're gonna search for this. We've got our 70 entries of this. So let's go to entry number 1. Let's just try to get all the way down to the entry we were at before. Okay, so here we go, pd.concat, looks good. And let's search for pandas dot, just in case I made that mistake some more. I didn't, okay. Alright. Alright, so this is the last entry. Finish it up just in the nick of time. And there might be some errors, but hopefully they'll be caught. And I can give it a once over. There's an error right here. All right, so it looks good to me. Oh, actually, it doesn't look good. All right, now it looks good. So that's number 69. So here's number 1. We've got concat. We've got everything looking good. So we'll just go through all 70 quick and give it a quick once over. It should stand out pretty easily if there's some errors here. What I'm looking for specifically is, did I forget the concat and did I forget the underscore df? That should stand out pretty easily. Okay, and this one we're just going to leave as is for now. And later in the next video, we might come back to figure that out. Or it might just, if it works, leave that one as it is and then not contribute to the author. But if we can get that one figured out too, then yeah, let's contribute to the author. Why not? So yeah, this is good to go. Saving it. So one last thing before ending the video, I want to spin up the notebook, which is already up. So let's take it down. Okay, and then let's bring it back up and see if this file now works better. So this is use case 5. This is the actual notebook file. So we're going to do kernel, restart, and clear all outputs. And then we're going to run down to the cell. So this should hopefully take it down from like a multi-hour runtime to a multi-minute runtime. Oh, and you know what? I think this was for use case 4 actually, because we can see we're not having any issues here in use case 5. I remember not having any issues. So yeah, this was long gone. So it's use case 4, but it's still worth doing because if we can get it to work, we might consider contributing it back to the author. I think the author might appreciate that. Again, the author's using it in Google Colab, not. So that's the other thing we can do is test it in Google Colab and see if that makes a difference. We have to be careful to submit only the correct changes because we don't want to submit this sort of change to the author where I'm taking it out of Google Colab. Okay, but this is the cell here where it creates that data frame. We can see it has a an interesting parameter, time delta. Now the time delta is 29 days. I remember that being set to something ridiculous. So we should get that warning message popping up for that last part of the code, but it shouldn't pop up until very later. That's the only time we've got this generate device metric time range, which is the cell that was taking so long. So we don't have that in this notebook. I think we have it in some prior notebooks, but for some reason it wasn't taking that long. So yeah, we have it here, but oh right. So the time delta, yeah, it took 4 minutes to complete. So I think, yeah, and now we're getting see how it's line 1901. So that's the line that we didn't change. So line 1901 is the line with the different sort of object to concat to the data frame. And remember, you can only concat a data frame to a data frame. So we have to convert that object to a data frame. And I'm just not sure what that object looks like. So I don't know how to do that just off the top of my head like for the other ones. Okay, but yeah, this is good. It's just all airing out on that one line instead of all those other lines. I'm a bit concerned though because the time delta setting is now in 29 days. I remember it was set to 10 hours somewhere, which is not good. Let's look for this some more. Yeah, so I only see it in 29 days, and then 4 minutes here. I remember something was set to 10 hours. I mean, days is longer than hours, so that is too long for me. But we can see we are at the end of the file, so hopefully But yeah, I've only got really if it doesn't finish in at most 5 to 10 minutes, then making these changes doesn't make a big enough difference. And we can ask ChatGPT. Let's ask it. So how long can I expect this line of code to take to run?
The runtime for the line of code you provided depends on several factors, including data size, the amount of data being processed within the specified date range, complexity of generate_device_time_range method, the computational complexity of the sans, generate_device_metric_time_range method itself, which can vary based on how it retrieves and processes data. System performance, the hardware specifications of the system on which the code is running, e.g., CPU, memory, storage speed. Database or API performance, if a method involves querying a database or API, the performance of the underlying database or API can also significantly affect the runtime. Here's a breakdown of the potential impact of each factor. 1. Data size IF the date range, 29 days, involves a large volume of data, it will take longer to process. The specific parameter, DNG_subscribers, and the device, P5 feet, might influence the volume of data, especially if they are heavily monitored. 2. Method complexity IF the method involves complex calculations, aggregations, or transformations, it will take longer. The method might also involve multiple steps like data fetching, filtering, and processing, each contributing to the total runtime. 3. System performance, faster CPUs and more memory can reduce the time needed to process data. SSDs, solid-state drives, will typically provide faster data access times compared to HDDs, hard disk drives. 4. Database or API performance, the speed of querying a database or an API can vary based on the query complexity and the load on the database or API server. Network latency and throughput can also affect the time if the data is being fetched from a remote server. Example estimation without specific details on the above factors, it's difficult to provide a precise estimate. However, you can get an empirical estimate by running the code and measuring the time it takes.
Oh.
Here's how you can do it using Python's time module. What to do next, run the above code to measure the actual time taken for a specific call. Optimize if necessary. If the runtime is too long, you might need to look into optimizing the method.
Look at that. It finished. See? So it's got that number filled in. Yeah, so that took it down from taking way longer than I could do in the video, hours, to only taking a few minutes. And it looks like I did basically the last thing I would ever want to do, and I ran it again. But let's start a stopwatch on it and see how long about that takes. So the good news is this time delta does not mean it's going to take 29 days to run. It'll take the amount of time to process the statement to run. So let's there we go. Now we got these warnings, so it's near the end of the file. Let's run these other cells as well. And keep an eye on the stopwatch. We're at 30 seconds. All right, coming up to a minute. And it's a bit longer than that because I started the stopwatch late, but it doesn't matter. It's just a rough estimate of the time. All right, so we're at 1 minute and it's still working. All right, minute 30 is coming up pretty quick. 3, 2, 1, minute 30, still working. All right, 2 minute mark is coming up very soon. Now it looks like the stopwatch ended when this cell ended. So we got a pretty clear time here. It took about 2 minutes for it to go through. And that's a lot better than what it was taking before. It was taking hours to go through because it had to produce these messages each time. And it was using this perhaps slower method that it was not optimized for because it's a deprecated method. So yeah, we could probably get this going even faster if in the next video we figure out what this looks like, this data looks like, and then we convert it intentionally over to a data frame that can be appended to the existing data frame. And we can do that definitely very easily. And then once we do that, we can actually contribute it back to the author. So really exciting next video. Exciting I got this to work. Unfortunately, didn't get any further in the reading, but this is important too. So thanks for watching and see you in the next one.